Hello everyone, in this video I'm going to show you how to plot temperature as a function of time and find out the temperature rise or delta T due to the chemical reaction in calorimeter experiment. So first you need to download the data files. In this experiment, the data file is saved as CSV format. So first you need to use Microsoft Excel to open these files. And here is the example. So I choose one of the data file and opened by Excel. And you can see we have 4 columns. Column 1 is time, column 2 is bucket temperature, column 3 is jacket temperature. Now in this experiment, we didn't use jacket, so ignore this column. And the last one is the delta T, and that's the temperature change estimated by the machine. Okay, so if you go down, you will see the machine estimate for this run to be about 3.1 degree change. Okay, so that's the machine estimated delta T. Now your calculation should be close to this number. Okay, so first let's choose time and bucket temperature. So select, use shift, okay, select these 2 columns and then insert chart and scattered plot. All right, so this is the temperature versus time. Okay, and you can see there are 3 stages. Okay, so and this is the stage where the reaction hasn't started yet, so before reaction, and this is when the reaction start, temperature rises. Okay, and then so that's stage 2, and the stage 3 is after reaction. Okay, so temperature stabilize again. Okay, note that in this data file we have the last data is obviously a outlier, and so we need to remove this data. Okay, and it's important that before the temperature rise, we need a straight line, meaning we need temperature to be stabilized. Okay, we also need to find the stage 3 where you need to find a range that the temperature start to stabilize. Okay, so to do that, okay, we need to find the temperature range. So first let me erase this. Okay, and if you use mouse to move, and you can find this data before temperature rise is 250. So that's the time. Okay, before this time the temperature hasn't rise yet. Okay, after 250 you can see temperature start to rise. All right, so write this temperature time is 250, and in this data file, okay, we choose from 0 to 250. All right, so that should be before the temperature change. Okay, let's plot again. All right, and you can see here, and this looks like different from stage 1. So this is stage 1, this is the same data. So even though they look different, they are the same. Okay, it's just different range. All right, so important thing we need to see is this straight line? In other words, is the temperature stabilized? So let's right click the data and add a trend line. Okay, so on the right side you see this window shows trend line. You choose a linear, and the display equation displays R, and the R is 0.9949, and that's a very good R squared, which means that this is a linear line. Okay, the closer to 1, the better a linear line. Now if your data find R squared is, let's say, 0.7, then that's not good. So you need to remove some data. Okay, for example, you remove these data, because sometimes when you just start the experiment, the data is not stabilized. So remove some data, find a range to become a straight line. So that means temperature stabilized, and then you start the reaction. So in this case, all data before reaction is a straight line. Okay, so we choose all of them. All right, so let's close this. All right, so now we need to, this is stage 1. We need to add stage 2 and 3. Now we first add stage 3 and make sure we also find the range so that it is straight line. So let's go back to the first first plot, and you can enlarge it, and you need to find a range that is a straight line. Okay, stabilized temperature. So from here I can see that around 700, so this data, around this data 710, and after this temperature or the time you have a straight line. Before this one, the temperature increase and then start to still change. Okay, so that's stage 2. Stage 2 temperature change, and then after 710 you looks like a straight line. Okay, and so write down the time. So it's about 710. That's the starting point for stage 3. Now you may look different. Okay, you may think it's maybe we can choose 690 or 720, and that's okay. You won't make too much difference. Just try your best to find a time so that you get a straight line after that time. That's the stage 3. All right, so let's go here, this plot, right click it and choose data, select data, and you add another series, and you don't need to type the name, just go to X. So we know it's 710, so start from 710 to exclude the last data. Remember, it's outlier, so choose the X range, okay, from 710 to 1150, and then go to Y. Okay, find the temperature correspond to 710. So 710 is here, and then go down here. All right, so now go back and you will see you have two stage 1, stage 3. Make sure stage 3 is a straight line. So let's add trend line and linear display equation display R. You can see R is 0.9988, so it's very good. Now if R is not good, then you need to remove some data. All right, and you need to find a range that is good straight line, and that means it's stabilized. That's stage 2 or stage 3. Okay, so we have stage 1 before the reaction, we have stage 3 after the reaction. Now we need to add stage 2. So again, choose the data, select data, and add. Okay, so now go to the data file, and the X start from 260 and end at 700. Okay, and the Y is the temperature correspond to 260. Okay, and here 1150. Oops, not 50. It's the stage 2 is 700. Sorry, so 700. Yeah, 700. All right, so 700 here. Okay, go back. Yeah, so we have clearly 3 stages with different colors. Okay, so at this point we can remove the first plot. Okay, so okay, go delete, cut. All right, so that's our plot for 3 stages. And at this point we need to extrapolate the trend line. So format trend line stage 1. All right, and we need to forward to around here 600. So it's about 400 times. So forward 400. Okay, so we have extrapolate the baseline, and then we extrapolate the other one. Okay, so format trend line, and this time it's not forward but reverse, so it's backwards. So backwards 400. Okay, all right. Well, actually, we can explore, extend a little bit more. So go. So here, oops, 400 to, let's say 500. Okay, so now we have extrapolate these 2 lines. So in order to find the temperature rise, first we use the midpoint. Okay, so this temperature, okay, this point is the time is 250. Okay, and this one is 700. So 250 and the 700, the midpoint should be 475. So somewhere here, 475, and we need to find a line, vertical line. So find vertical line, that's the midpoint, and then the intersection are estimated temperature change. So this is temperature delta T. Okay, all right. So let's put here. So this is the equation, and the time, midpoint time, let's write here 1, 2, which is about 475. Okay, that's the midpoint time. And we want to calculate delta T, so we need to calculate the intersection. We use this equation. This is the equation for the line. So copy this equation to here. All right. So in this equation, x means the time. So time here is 475. So in the equation, we need to change x by multiplication of this 475. So click this cell. Okay, and so 29.287. So this point is 29.287. Okay, similarly we copy this equation. All right, here, and change x to multiplication by the time midpoint. Okay, so this time temperature is 32.3815. So delta T can be calculated, the T2 minus T1. Okay, so what we get is 3.0945. Okay, so delta T is 0.945, and that's estimated by the midpoint. And remember, the machine calculate is 3.10. So this is very close actually to the machine estimated temperature change. Now the correct procedure is that we need to find a vertical line so that the height here is about 63% of the total rise. And so then these two temperature change will be the correct delta T. So we already use middle point, we estimate the center, the temperature change is 3.0945. We need to multiply by 63%. So 63%, and where's the percent of the temperature rise? You use this total rise, so equals the total rise times 0.63. Okay, so 1.949. Okay, so the this height should be 1.949. So we need to find this point. Okay, and this point should be, the temperature should be the rise plus this temperature, be the baseline. And baseline we can use the lowest one, 250. When time is 250, and so 250 is here. Okay, so we need to add this temperature. So the temperature should be, let's say this is TB. Okay, so TB should be, all right, and click this this one. Okay, let's click this one too. That's temperature at 250. So equals 250. So click this temperature plus the increase. Okay, so TB should be 31.28184. All right, so let me erase everything in this diagram first. Okay. Now if we move the cursor, all right, you will see this point is 300 times 300 seconds, temperature 30.53. Move to here, temperature 30.8, 31.0, 31.2833, and you can see this point is very close to 31.28184. So close that we can just choose this data. Now, if it's not very close, it's between these two. Okay, then you make a linear insertion between these two data, find the data, maybe half of it. Okay, you can do that. But in this case, it's 31.28, 31.20. So we can just assume that's the data. The time is 330. We need to make a vertical line to vertical line go through this point. All right, to do that, so the time, make sure write down the time is 330. So let's write here 330. That's the time, and we want to make a vertical line so that the top is above this trend line. So let's say this is 32.8. Okay, so 32.8, and the other point is below the bottom trend line, so it's about 29.1. So 29.1, and the time is still 330. Okay, we want to add 2 points, these 2 points, and plot a vertical line. So to do that, we select the data again. We need to add, okay, a x is same here, but y is this 2. Oops. Okay, so let me do it again. Okay, there now you see 2 orange dots. Okay, that's the, we want to make connect these 2 dots to find a straight line. Okay, so so we have to, okay, let's click this one and add trend line. Okay, so solid line. All right, and then choose dot line. Okay, so now we have a vertical line, and this vertical line go through this point, which we calculated the height here is about 63% of the total rise. Now you can you can make sure, check if this is 63, around this 63% of the total rise. All right, so what we need to do now is to find these two temperature intersection. So similarly, all right, we need to write down here the time is 330. Okay, let me see the time TB, okay, is 330. Okay, and then we need to calculate intersection with the two trend lines. So copy the bottom one. Okay, change x to multiply by the time. Okay, so that's 29. So this point 29.316. Okay, that's this intersection here. All right, and the top one, copy and paste. So copy is Control C and paste Control V. All right, and change x by multiplication with the time. Okay, so this point should be 32.425. So to calculate the delta T, we can use, okay, T2 minus T1. Okay, so that's 3.109, and that's very close actually to the machine estimated. All right, so for the report, all right, you need to make it look good, better. So you can remove this. Okay, remove this. Okay, and let's add something. So here you can add x title. So here change to temperature. All right, and make it larger. Let's say 18. Okay, so that's temperature, and this is time, seconds, (18). All right, and here you can write your sample. Maybe let's say naphthalene. All right, naphthalene maybe run number number 3, for example, and temperature versus time. Okay, and the linear equation, you can make it even a little bit larger. Let's say 12. Similarly here, make it larger. All right. Now to add these two temperature, we can insert a text box maybe. So here it's the temperature of the initial final. Okay. Okay, so make it larger. 28. Okay, that's the initial temperature. Okay, which is according to our calculation is on the right side. is 29.31. Okay, 6. And on the top, oops, this temperature is here. That's the final temperature. It's 32.425. Okay. So that's the plot that includes initial temperature, final temperature, and you can do other things to make your plot looks better. And in your report, you plot this, and you need to have a table to list your results. Okay.